Hello, I am Joshua P. Warren, and I have something cool to show you. This little motor right here will spin and spin until the cows come home, as long as there is light, but it's not hooked up to a battery or anything like that. This thing combines three of my favorite things: light, electricity, and magnetism. It's called a Mendocino motor. And that's because the man who invented this had a workshop in Mendocino, which is on the coast of California. So this is the Mendocino motor. And I'm going to stop it for a second, and then so you can get a better look at what this thing is. For one thing, it's just hovering, this little spindle or shaft. It's just hovering right there. It's levitating over these magnets. And you know what? As soon as I saw this, I was reminded of one of these. Maybe you've seen one of these before. This is a little like magnetic levitating desk toy that I bought years ago. And it's been beaten up pretty bad, so I don't know how well it's going to work. But you see, it's the same concept. You just spin that thing, and it sits there and spins and spins and spins for a long time, because the only point of friction is this little tip right here. There's like it's like the tip of a needle that's on this piece of like hard plastic. I guess that's plastic, yeah, hard plastic. So that's the only place it's actually touching. So you see, it's these are just magnets. There's a magnet here, a magnet here. There are magnets in the base. And if you get it balanced just right, it just sits there and floats. And so when you spin it, I mean, it'll spin for a long time just from the momentum you give it, spinning it with your fingers. But this thing, now this will spin forever. So again, this is very similar setup, except on this one, the inventor has added solar panels. And there are coils of wire also inside this little box. So when you pass electricity through a coil of wire, the wire acts like a magnet. And of course, you know how magnets push away from each other or attract to each other. So basically what he's done here is create a system where the solar panel is sending a current into a coil, and when that coil becomes electrified, it pushes away from the magnet that's near it. And when it pushes over, well, the same thing happens. Now the next panel sends current to another coil, and so on, and you just barely get this thing going, and you'll see it actually starts to pick up momentum. And right now, it's the evening at my house, and so I don't even have much in the way of any sunlight, really no sunlight coming in here. It's dusk, so the only light is just coming from, there's an incandescent bulb here over my head, and I happen to have a little light over here just for filming purposes, but it doesn't matter. I mean, I've had this for about a week now, and every time I walk by it, it's just sitting there spinning. I mean, if you get up in the morning after a dark night, then it might stop, and then you just give it a little nudge. You could basically blow on it and it starts right back up again. And you know, it's funny, you can't help but look at something like this and think about people who've been trying to create perpetual motion machines for centuries, probably even thousands of years. And supposedly a perpetual motion machine is impossible. Because to build such a thing would violate the laws of thermodynamics, which is a pretty big deal. I won't get into that right now. But even though we might not be able to build a perpetual motion machine per se, even though, by the way, in the quantum world, there is such a thing as perpetual motion, but we won't even get into that rabbit hole. Even though you might not be able to build a perpetual motion machine per se, we still have things that are what I call virtual perpetual motion that will operate infinitely in terms of a human lifespan. So solar energy would be an example of that. As long as the sun is shining and your solar panel is unobscured, it's going to provide power. So I would think of a solar panel as being something like virtual perpetual motion. And you could say the same thing about a windmill or a water mill, a water wheel, you know, things like that that are tapping into forces of nature that are lasting long enough for you to be able to be productive in your life. I've always thought it would be cool to figure out some way to use gyroscopes to tap into the Earth's rotation and see if you could actually get something that will spin because it's magnifying the spin of the Earth. I don't know, look into it. Maybe you can come up with something. So you see, this is not really perpetual motion because actually it's really just another solar motor. I mean, you could just have a solar panel hooked to a motor and the light hits it and it spins the motor. But this is just another way of doing it, which is a lot cooler because, you know, it's levitating and it's very efficient in many ways because, again, you only have that little point of contact right there. And this is actually quite heavy. I don't know how heavy it is, but it's pretty heavy. And you can see it spinning this little propeller like a fan blade. So it's not really throwing off much, to be honest with you, but you could think of it as a novel fan, right? But it's kind of cool to think that just light is turning that, and it's very, very sensitive. You see, obviously, this little magnetic desk toy, it's already stopped spinning. When you start looking at how that we can tap into light in order to create mechanical motion like this, you can't help also but think about this device. This is called a Crookes Radiometer. Now, if you study physics or even chemistry or, well, really the scientific world at all, you've probably seen one of these. Now, the Crookes Radiometer is, these are basically little metal pieces that can rotate inside of a vacuum. So this is similar to the inside of a light bulb. And what happens is, okay, if I take this bright flashlight and shine right on it, then you can get it to move a little bit. But it really spins fast in the sun. And also I've got a decently powerful laser here, which kind of looks like a lightsaber, doesn't it? There's my cool lightsaber laser. So I got to put on safety glasses to use this. So watch what happens. It stops spinning. Now I'm going to hit it with a laser. And the laser gets it going a little bit, but it's still spinning pretty slow, even with a laser. But watch what happens when I put it under this incandescent light. Let's see if we can do this. There we go. So when I put it under the incandescent light, it starts spinning much faster and building up a lot of momentum. Now, the funny thing is, for at least a good 10 years after this was invented by the English scientist Sir William Crookes in the 1870s, there was no real consensus on exactly why this would spin when it was put into light. And for a long time, people were saying, well, maybe it's photons that are bouncing off of these panels, and those photons are creating this physical force that we see inside. Now, there's still not a 100% consensus, but a lot of scientists I've seen are saying that they believe that this really isn't so much about light as it is about heat, that it's kind of like a heat wheel. But the funny thing is, on numerous occasions, I have put this radiometer in front of a heater and have heated it so that, I mean, it's hot to the touch. and it won't spin. I can't get one of these things to spin if I put it in front of a heater. So I have questions about whether or not we still know everything about what makes one of these radiometers spin. Because it seems to spin better under incandescent light and sunlight than it does with like an LED light or even a laser light. And yet I don't have any consistent results spinning it in front of a heater. So I'm still thinking there might be something about light, some property that's being transmitted by light that we haven't quite understood yet. And maybe if we can tap into that, whatever it is, maybe that will be the key to us creating a much, much more effective solar cell or solar panel or something along those lines that will give us the type of power that we really are trying to get out of solar technology. And by the way, look at how that's spinning, the radiometer, and under the same light conditions, basically, look how this is spinning, the Mendocino wheel. See how fast that's going? And it's going to be doing that, until I turn the lights off later. So it's kind of cool. Maybe one day I'll have a room where I surround myself with just a bunch of stuff like this and see if I can figure out what makes some things spin better than others. So perpetual motion, not exactly, but it does make you start thinking more about the options. So I'm going to be doing more experiments, playing around with this stuff. Maybe you've learned a little. Maybe you just find this as cool as I do. Either way, if you like this kind of stuff, please be sure to subscribe to my channel. And you can also follow my work by signing up for my free e-newsletter at joshuapwarren.com. That's joshuapwarren.com. Thanks for watching.